some of the people who work at the College of Charleston. So that's what I'm going to do now. So I'm talking a little bit about myself, and some of the presenters are going to talk a little bit about themselves. And I want you to talk a little bit about yourself. Would love for you to turn your camera on if you're in a setting that you're able to do that, so we can actually see you. And I would love for everybody right now to pull up the chat and type in, just like I did, your name, your major. So I'm a computer science major. I already graduated, but that's my background. Where you're from, right? I would love to see where you're from or hear where you're from, where you're joining us from tonight. And then a fun fact about yourself, like a hobby or something like that. I try to play the guitar. It's terrible, but it's definitely something I enjoy doing. So please do participate. Plug that information in the chat box so that we can kind of learn a little bit about you as we kind of talk at you a little bit during this Zoom session. Yes, Sebastian Vandelden, computer science major. Grew up on this small island in the Caribbean called Saba. Only 1,200 people live there. It's only a 5-square-mile island. Came to America, went to UCF in Orlando, this huge mega university. Very different day-to-day experience that you'll get from compared to here at the college. And married me an American woman. Been in America ever since. Got my dream job here at the College of Charleston, and the rest is history. So that's just a little bit about me. I'm going to come back in a second to kick off our little slideshow after Dr. Corey tells you a little about himself.
Hey, I'm Dr. Chris Corey. I'm a faculty member in the biology department, but also the associate dean in the School of Science and Math. I've been at the college for 19 years. My research area is molecular genetics and neuroscience, invertebrate nervous systems like fruit flies and crustaceans. When I teach here at the college, I sort of specialize in teaching first-year students, so intro bio classes in the first year through the first-year experience. I also teach genetics and molecular biology. And my role here is really to transition you onto campus and make sure you're successful in your first year, as well as do a whole bunch of things to make sure you're successful for the next 3 years after you get here. So looking forward to seeing you on campus, and I will turn it back to Dr. Vandelden.
All right, thank you, Chris. And you'll get to hear a little bit from each of our department chairs as the program unfolds tonight. So before I share screen to walk us through the slide set, one thing I'm going to talk about is that I do a tour for admitted students like yourself almost every Friday at 3:30 p.m. Would love for you to join me in person, and we explore some of the science buildings here on campus. For example, I'm standing tonight in one of our material sciences labs. So would love for you to get in our spaces and check out some of our labs. So just in this one lab here tonight, there's all kind of gizmos that you can get to use while you're an undergraduate student doing research with our professors. For example, in this lab right over here, we have an atomic force microscope. We have a laser measurement system. We have various systems that do material testing. Boeing, for example, will send us pieces of their aircraft. This is like a little tip of the nose of the plane here. They send us various materials like this carbon-based fiber, and then we do various testing processes in our labs as part of our undergraduate research programs. In the back of me here, there's an ultrasonic NDT device. There's an X-ray machine back there, and a very powerful electronic microscope. That's just some of the toys we have to play with in this one lab here at the College of Charleston. This building I'm in is a 150,000 square foot facility, one of 2 big science buildings here on campus. I promise you, if you come visit in person and I show you around, you're gonna like it, you're gonna be very impressed. So that's why I'm standing here in this room tonight. I'm gonna share my screen and jump into the slideshow. All these smiling faces looking at you here are recent graduates from our computing programs. Professor Stalvey is at the Harbor Watt facility tonight, so she can look out the window and see that beautiful view from our computer science program. Why come to the College of Charleston? If you are joining us, especially from out of state, if this was 20 years ago, we'd be standing up here telling you, oh, you gotta come. We have awesome beaches, we have a cool downtown, it's a great school, it's a historic liberal arts school, you get quality education. That's all still true. But the reason why you need to come to the College of Charleston is that It doesn't matter what you pick as a major, there's something for you to do in our research labs here on campus, but also with the many campus partners we have right here in the region. Did you know that Charleston is the only city in the world that makes both planes and cars in the same city? Boeing makes the Dreamliners here in Charleston, Volvo makes sedans, and Mercedes makes the E-Sprinter vans. Did you know that Google has the third largest data center in the world right here in Charleston? But the biggest major at the College of Charleston is biology, because it's a popular choice. The students want to matriculate at the MUSC, the big medical university that's 3 blocks down the road from us, to continue on to do their MD or DMD or PharmD or whatever type of health profession they kind of want to go into. Our marine biology program, one of the top in the nation, because it's co-located with NOAA, NIST, and DNR on our Fort Johnson campus. Over 500 tech companies in the area, numerous analytical chemical companies in the area, pharmaceutical manufacturing companies, and everything in between. So lots of ways that you can apply what you're learning out in the community via one of these institutions or companies while you're still a student here at the College of Charleston. My last slide, my second to last slide, these are a couple of pictures of our students engaged in some type of experiential learning opportunity, undergraduate research with our professors, targeted study abroad, faculty-led programs with our professors, or internships out in the field. So there is something for you to do in Charleston, in our labs at the College of Charleston while you're an undergraduate student, to prepare you for that next step in life, graduate school, or that first job right out of college. So I really do hope you'll join me for a STEM tour in March. I'm doing them every Friday in March. So I got this Friday, the next Friday, all throughout March. In April, we're doing other admitted students events, so it's not so much in April, but I really do hope you'll join me for that tour. Send me an email and I'll point you right to the sign-up sheet and how to get into my tour, and so we can explore some of these facilities together. That was my last slide. So with that, I'm gonna kick it back to Patrick.
Wonderful. Thank you, Dr. Vandelden. I'm now pleased to hand it over to Eric McElroy, who's with our biology department, to talk more about some of the great things in the life sciences area that our students can get involved with.
Eric, don't forget to unmute, Eric.
I should know better. I'll start again. So thanks, Patrick. I'm Eric McElroy, Department Chair of Biology. I grew up in Northern Ohio, did all of my school in Ohio, got my PhD 13 years ago in ecology and evolutionary biology at Ohio University. I've been part of the faculty in biology here for 13 years. I am particularly interested in animal locomotion, how animals run and swim, and have an affinity for studying lizards. Something personal about me, I'm an avid basketball player. If you come to the College of Charleston, you'll probably find me over at the gym on Friday at noon playing basketball. I've been doing it for 13 years. I'm broadcasting to you here from the Human Anatomy and Physiology lab at the College of Charleston, so you can see some of my friends behind me here. If you come to the college and you're interested in healthcare and medicine, you will very likely find yourself in this room learning about the anatomy and physiology of humans with me. I teach in the Human Anatomy and Physiology curriculum, or with one of 5 or 6 other professors. The slide you're looking at has some information about the Department of Biology. So I have sort of our mission statement here at the top. We are an inclusive academic and we provide an inclusive and academic and research environment for the rigorous investigation of the science of living systems. And I think what our department really prides itself on is that many of our students get involved in undergraduate research in our laboratories. And so the way that we make that work, we have 50 faculty that help students get involved in research. We offer degrees in biology and marine biology. Somewhere in the neighborhood of 120 to 140 students each year are involved in research projects directly with faculty here at the college, down the road at MUSC, and also out at Fort Johnson, where we have partners with the Department of Natural Resources and some federal facilities. Our faculty are successful in acquiring grants and publishing papers, and those are important for students because the grant money supports world-class research, and the publication is a great way to get your name out there and build your resume for thinking about things like graduate school, medical school, etc. And our students find success. So we have physicians regularly matriculate from this department, dentists, scientists, technicians, lawyers, policymakers, lots of success stories for biology graduates. We also have multiple state-of-the-art facilities in biology. So we have a marine lab that is on the Charleston harbor. You can literally walk out the back door of the marine lab and you're on the harbor with what I think is the best view in Charleston. The college as a whole has a 1,000-acre nature preserve called the Stono Preserve. Biology uses it heavily for both courses and research. We are housed in the Rita Holling Science Center, which was renovated. The renovation was finished about 4 years ago, so it's really still a new world-class facility. And our faculty are international in their research. So we lead several study abroad programs and also have faculty doing research in the Virgin Islands, Hawaii, and the Arctic. And they take students to all of those places to do that research. If you're interested in more information about biology, you can shoot an email to the address listed on the middle of the slide. You can also check out our Twitter, Instagram, and other social media feeds. Back to you now, Patrick.
Great, thank you so much, Eric. Now, happy to turn it over to Karen Eipert. Karen is our pre-health advisor, and I'll let her talk a little bit more about herself and what that program looks like here at Charleston.
Hi, everyone. My name is Karen Eipert. I'm the program director for the pre-health advising program. So Eric and his department train them, and then they send them on to me to help you get your feet in the door at the medical university. As Dr. Vandelden mentioned earlier, 3 blocks down the street, we have the Medical University of South Carolina. It is the only academic medical center in the state, the only teaching hospital. So they have a level 1 trauma center, a brand new children's hospital, wonderful research area, and 6 individual colleges. So basically, you can expose yourself to almost any area of medicine just by walking down the street. If it's raining, you can take the Carta for free, or you can jump on your bike. Right next door to MUSC, we have another major healthcare organization, Roper St. Francis Hospital. They have a wonderful volunteer program, and they will go out of their way to help get you into areas of the hospital that interest you. So they'll get you into the OR if you're interested in surgery, give you a chance to really see what the day, in the life of a surgeon is like. And then just beyond that is the Ralph Johnson VA Hospital. We have a very active VA hospital here in South Carolina. Obviously, you'll see a different patient population there and deal with some really wonderful, interesting people. We don't have formal declared majors in healthcare. I personally see that as a plus. I worked at the medical university for 12 and a half years before I came to the college 16 years ago. And so my role here is not just to help you get into or find out more about the profession in healthcare, but to help connect you with volunteer opportunities, internships. We actually, in the past couple of years, have had a number of clinicians in the area who are now calling and requesting gap year students, because gap years have become so popular nationally for medical students, where they'd like to employ you in their office and mentor you while you're applying to medical school and interviewing. So those opportunities are amazing and offer amazing opportunities for you as a pre-health student. If you notice on the slide, you'll see the EMT program. Getting certified in something prior to applying to a clinical program, it's mandatory in many programs, but anything that you get certified in that actually allows you to lay hands on a patient gives added value to your application. Our EMT program has recently gone through a major reorganization, and we're so excited. We have a wonderful program director who's actually one of our alumni. We're going to lose her, though, because she's just recently been accepted to a PA program at Yale University. So, but the students are, even though it means additional shifts and added work, usually the students will say it's the best part. They love it. They're happy to work weekends and do shifts on the ambulance. And what they learn is just invaluable. One of the reasons that I think not having formal declared majors is a plus is that sometimes students come to the college. Maybe the idea of being a physician came to you when you were in the 8th grade, and you've been thinking about it ever since. And then once you get here, and you start to gather more information, you start to get into upper level classes and realize exactly what that commitment means. Every once in a while, somebody decides to change their mind. They want to look at PA school, or they want to look at another area of healthcare. What I want for you is to find the work that you find most rewarding. So at that point, you'll be encouraged to do it early. But the sciences that you'll be taking as a freshman, if you are a pre-health student, will be transferable into almost any major you want to go into. About 85 to 90% of our pre-health, pre-med, pre-dent, pre-vet students are science majors. A Bachelor of Science in Biology will cover everything that you need for those programs, with the exception of a semester of biochemistry. And for many of the allied health programs, they tend to be a little bit less rigorous in science, don't require organic chemistry, don't require calculus, but excellent careers. So for students who are not as strong in math and want to go in another direction in healthcare, there are many doors for you to open. We have over 1,000 pre-health students on our campus at any one time, every year, annually. Actually, it exceeds that a little bit. And so it takes a village. The faculty in all the departments are extremely helpful. And as far as undergraduate research in healthcare, there are many, many opportunities for it. I also employ 2 pre-health peer mentors who are rising juniors and seniors, and they are here. They hold advising hours in the School of Science and Math. And obviously for the last couple of years, they do it virtually too. And they're here to help you, encourage you, support you, give you some advice about things they've done, things they wish they hadn't done. So the advising level here for pre-health is another level of advising in addition to your major and the academic advising center to keep you from falling through the cracks and help to make sure that you're competitive for whatever school you want to go to. We currently have students at Emory University in Atlanta. We have students at Johns Hopkins in Baltimore, and obviously we have many students who end up staying in Charleston. When they get here, they want to go back. So if you would like any additional information, please don't hesitate to email me. And if you go on the website, you'll find a link for Ask a Peer Mentor, and you can directly ask them a question, and they're great about getting back to you. Thanks for your time, and I'm going to turn it back to Patrick.
Great. Thank you so much, Karen. Always good to hear from you. Next, we're going to shift over to the chemistry department, and I'm proud to hand it over to Jim Dever.
Hello, everybody. Thanks for tuning in tonight. I am Jim Dever. I'm from Brevard, North Carolina originally. Went to Mercer University, got my undergraduate at the University of South Carolina, the graduate school. I'm the interim chair of the Department of Chemistry and Biochemistry. And I've only been at the College of Charleston for only 38 and a half years. So, but I've loved it here. I tell people I would not have done anything else anywhere else. And my daughter is actually a student here at the College of Charleston. I tried to get her to look at other places to go, but no, she was set on coming to college after she did look at a couple other places. And she's actually over in the School of Business and the Hospitality and Tourism program. And she will graduate in May. So I'm looking forward to celebrating that with her. Chemistry is a central science. I'm an analytical chemist. Analytical chemists analyze things to see what you have and how much of what you have. And we have lots of neat instruments in our department. So behind me is the nuclear magnetic resonance spectrometer. It's an instrument that you've probably heard about MRI, magnetic resonance imaging in medicine. Same physical phenomenon. where you're looking at interaction of radio waves, the magnetic field with molecules. A physician uses that to determine whether you got maybe a cancer tumor, a broken bone, or torn ligament. We use that same physical phenomenon to actually identify the structure of molecules. And you'll be able to use this type of instrument, some other instruments I'll be talking about shortly in your career here, especially in the upper level labs. You'll get to come in here and put your sample in the instrument and determine what that structure is. We have some really cool courses at the College of Charleston, such as environmental chemistry, the biochemical basis of disease, instrumental analysis. And this year, thankfully, with COVID relaxing, we've got a field course going to Ecuador. And they will be looking at water quality in an indigenous village and doing a water survey of the area. Besides the NMR, we have some instrumentation such as a polymerase chain reaction that you may have heard of. We have an instrument that does that. The HPLC-MS, high performance liquid chromatograph mass spectrometer, that's the type of instrument that's used like in the Olympic Games to do drug analysis of athletes. The MALDI-TOF is another mass spec instrument that is used by Jay Forsyth in his research to look at the origins of life. We send our students on from here to get jobs in the industry, to go to pharmacy school, to graduate school, and all sorts of medical and dental schools across the country, but particularly up the street at the Medical University of South Carolina. Undergraduate research is so important. We really like for our students to do that so that you get a taste of what doing chemistry and biochemistry is really like. You do undergraduate research in chemical biology. You can look at enzyme function and structure. You get to clone some genes, do molecular modeling on the computer, look at nanoparticles. Already mentioned the origin of life, and you can see that MALDI-TOF instrument right above where it says research instruments on the slide. You make polymers, study polymers, especially possibility of drug delivery within the body. You can look at protein-protein interactions. We have physical chemists that look at quantum dots. And another one of my analytical chemistry buddies looks at drug degradation. What happens when you leave your Tylenol in the glove compartment over the summer, for example. We do offer degrees in chemistry and biochemistry, and both of our Bachelor of Science degrees are certified by the American Chemical Society. That's a quick overview of our department. There's our website. There's all sorts of information that you can find there, and more than happy to answer any emails or phone calls or take you on a tour when you're in town. So thanks for tuning in to Chemistry and Biochemistry, and I'll toss it back to Patrick.
Great. Thank you so much, Jim. As we start to shift into another section here, I would encourage you, if you do have questions that are maybe on the tip of your tongue or you don't want to forget about them, please feel free to drop those into the chat feature here on Zoom, and we will, as we get through the last of these, we will have a chance to go through and answer any particular questions you may have. But without any further delay, I'm going to hand it over to computer science and have Roxanne Stalvey give us a wonderful introduction of that program.
Hey, so my name is Roxanne Stalvey, and I am so super excited to be here with y'all. I am the Associate Chair of the Department of Computer Science, and am happy to speak to y'all and tell you a little bit about what we offer here in our department. And I want to start that by telling you a bit about this really awesome space that I'm in. I'm in one of our newest faculty members' labs. She calls it the CAT Lab, stands for Critical Art and Technology Lab. And in this lab, she has really cool things like you might see over my shoulder here, some sewing machines. Why would a computer scientist need sewing machines? She and her undergraduate students are actually developing wearable technology using conductive thread. Over my right shoulder, you see a workbench. She has a soldering station over there and some woodworking tools. And then if I can turn my camera, you might see, if you check it out, a laser cutting station and a vinyl cutter. The laser cutter is great for cutting wood and plexiglass using vector graphics, and then she uses engraving using raster graphics with that system. The vinyl cutter, how cool is this? And you, if you come to the College of Charleston and join Computer Science Department, could be a part of this really cool research. She's actually cutting vinyl letters and creating interactive wall art by embedding circuitry into this vinyl wall art. And of course, there's virtual headsets, these VR headsets she's using with different students who are involved in gaming. Let's see. So let's talk a little bit more about our department. Our department is fantastic. We have a really awesome space. If you look at the slide that you see there, that's actually looking right outside of where I am right now. I'm looking out over the Cooper River Bridge in the Charleston Harbor. So our space is beautiful. We have 3 floors where we have all of everything that we do in one location. We have our classrooms here in Harbor Walk, looking out over this space. We have our offices, our research area, and then we also have a fantastic space for students to check out different equipment like drones, use some robotic equipment, actually play video games if you want to just take a break from studies, but also a really great study space for our students to use. Our students are about 30%, actually over 30% women, which we're really excited about. It's unusual for a computer science department to have such a high population of women, and they're fantastic, both women and men in our department. There are 5 different degrees here in our department. We offer a degree in computer science, which is our most popular degree for sure, but then we also have some really unique degrees. We have a degree in computing the arts. Computing the arts is the only major of its kind in the state of South Carolina and is really unique throughout the country. We also have a fantastic degree in data science and in computer information systems. Where computer science is straight computer science, computing the arts allows an opportunity for students to combine computer science with an arts area. And data science focuses heavily on data. The students who leave with a data science degree are doing a lot of data analytics for different companies around the world, and some of them are going into graduate programs as well. And then finally, our computer information systems degree that I mentioned combines computer science with a business focus area. We also have 2 master's degrees. Our computer science master's degree and our data science master's degree are housed right here. Our computer science degree is a 4+1 program. So if you are a student who is ready to hit the ground running with your computer science studies in your freshman year, then it's very easy for you to spend 4 years here at the college working on a bachelor's degree, but then in your junior and senior year, take courses toward a master's degree, and then use 1 more year to complete a master's degree in computer science. So in 5 years, you can have 2 degrees, which is pretty exciting. We have 16 faculty members and 9 research labs. So we have some really fantastic research spaces in addition to the one that I'm sitting in right now. We are very proud of our students. Our students go on to get jobs from places that you've heard of, like Facebook, Amazon, Google. We've sent students to Microsoft. We also have a lot of our students at companies a little closer to home. Capgemini is a very large consulting company, but they have offices in Columbia, South Carolina, and they hire tons of our students. As well as we've sent students to Disney, American Express, and Apple. So some fantastic places, but then also places close to home. A lot of our students do go on to do graduate school work, and you see there that a lot of that studies have gone to places close to home and as far away. We are a fun faculty. We are a great group with a great group of students. I think you'll really enjoy our space. So we hope that you can come and visit us, kind of see what we're all about. and enjoy the opportunity to learn more about computing. If you have any questions, please don't hesitate to reach out to me. You can find a link to my email here at our website in that upper left-hand corner. Our website is compsci.cofc.edu, and there you can also find lots of information about our program. So without further ado, we hope to see you in computer science. Back to you, Patrick.
Thank you so much, Roxanne. Now switching over to geology, I'm happy to hand it over to Scott Persons.
Oh, so I'm Dr. Scott Persons, and I am not a department chair. As a matter of fact, I'm the newest member of our geology faculty. But our chair has tasked me today with giving you an introduction to geology. And frankly, that's a tall order because in our department, we study an awful lot of stuff. Geology is a very broad science. We study rocks and dirt and volcanoes and earthquakes and climate change, the distribution of pollutants in the environment, the formation of mountains and rivers, the surface of the seafloor, the composition of other planets, and in my case, the evolution of prehistoric life. Now, I'm coming to you live from the Mace Brown Museum of Natural History, which is an incredible resource on campus that houses thousands of fossil specimens, all of which are available for student research. I've got several students right now that are working on projects from things like measuring baby dinosaur teeth to identifying the armored plates of big herbivorous dinosaurs to most recently tackling the question of whether or not there might actually be multiple species within the animal Tyrannosaurus. I'm very proud to say that coming up this fall, our department is poised to launch a brand new concentration in paleontology, something very, very few institutions across the nation have got. Now, as you might imagine, geology tends to be a fairly outdoorsy science. And as a result, we've got lots and lots of field studies courses. Those include courses in really cool places like Northern India or South Africa, and in lots of spots in the American West. And this summer, I'm heading out to Wyoming with a group of CofC students to launch a dinosaur hunting expedition. We'll be working in what we call the Lance Formation, which is a unit of rocks from the very, very end of the age of dinosaurs. And we're looking from bones for critters like Tyrannosaurus, Triceratops, and duck-billed dinosaurs like Edmontosaurus, which happens to be the animal directly behind me. So if any of that sounds like fun to you, I encourage you to scan that QR code that's there on your screen and then click on prospective students. I'll wait. All good? All right. Well, I hope to see you all in class. Patrick?
Wonderful. Thank you so much.
Patrick, real quick, before we go on to our next speaker, I wanted to point out a fun fact that Scott would never mention himself, but Scott, Dr. Persons, who you just heard from, is credited with discovering the largest T-Rex in the world. And so he's super famous, and we're super happy to have him here. Great job, Scott.
Yeah, and it's worth mentioning that we've got a cast of that enormous Tyrannosaurus skull just outside the museum here. You'll see it if you take Sebastian's tour.
And if that energy is any indication, I'm looking forward to hopefully a forthcoming YouTube series from Dr. Persons as well. Wonderful. So like I said, as we move on, we have two more presentations to go through today, two different areas. But please do, if you have any questions, feel free to put those into the chat box. We'll be having the chance to do some live questions and answers in just a minute here. But I am very happy to now turn it over to math, and particularly to have Liz Jurisic talk us through some of the program details.
Hi, thanks, Patrick. Hello, everybody. I'm Liz Jurisic. I'm the chair of the mathematics department. And you see me there in this picture with my email address underneath. And of course, reach out to me at any time. And then the next picture under me is Dr. Kate Owens. She's our associate chair. I have a PhD from Rutgers University in New Jersey. My specialty is representation theory and algebraic systems related to mathematical physics. Kate has a PhD from University of South Carolina, and she works in another type of algebra. And she's an expert in some aspects of teaching math, including mastery grading and exciting things like that. So we are going to be happy to see any of you guys. If you do come tour, if you come to the college, drop by the math department anytime, talk to us. Even if you're not a math major, you'll be in some of our classes. So I'd like to start with some places where our graduates work. Again, we've got people working all over the country with their mathematics degrees, including a fair number in banking. I have Citibank on there. One of our students is a fraud detection agent at Huntington National Bank. We have folks locally at Blackbaud. We have people working at big companies like Samsung. One of our graduates is at Refinitiv in Boston, which is a management consultant company. We have folks at State Farm, the Medical University up the road. The Naval Information Warfare Center likes to hire both our bachelor's degree students, and we have a master's degree student or two working there. The Department of Defense, Charleston County School District. Again, we have undergraduates with education degrees specializing in math there. And we also have master's degree students there. And the little rabbit there is a e-commerce startup clothing company in Los Angeles, where one of our graduates works, doing whatever math, stat, logistics, finance, this little tiny company happens to need. So we do have a good placement. Any degree in mathematics or minor or that nature is in high demand, both in the Charleston area and other places. So I'll move on to our different flavors of math degree. We have several tracks: statistics, actuarial studies, which is basically statistics with some business classes mixed in, like a minor in business. And we have pure math and also applied math mixed in there. Additional programs, mathematics teacher education. I've already mentioned that one. Data science is a shared program with the computer science department. You've already heard that spoken about. And we also have a combined BS-MS degree that you can get in 5 years. And then we have standalone master's degrees as well, both in a mathematics flavor and a statistics flavor. And we have a certificate in operations research. So we love to work on our own research and have student research projects. You can see a collection of students in this picture. There is a professor in the background and 2 undergraduates in the foreground and a grad student in the background. And I think that's one of the things that's nice about us at the college. We can have groups working together from graduate students, undergraduates, professors. I put some recent titles of student research projects up there: solutions to the matrix KdV equation, the Cordovare's equation, some dynamical models of targeted advertising, neural networks, a GDD, that is a technical term for a type of design using Latin squares, chaotic dynamics in perturbed nonlinear equations, and that would be applicable to, say, fluid dynamics. And then a nice thesis on the work and life of Karen Uhlenbeck, who was recently the first woman to be awarded the Abel Prize. So we love our summer research and projects with students. We have faculty. Of course, our main mission as the math department faculty is to teach. We really enjoy our smaller classes that you encounter at the College of Charleston. We can give you some extra personal attention because our classes are not large. And then our faculty also maintain active research programs. So we have a variety of areas here, ranging from dynamical systems applied to both linguistics and then biology by different faculty. We have people who work in mathematical biology, mathematical physics, waves, nonlinear waves, integrable systems. And then we have folks just working in pure math like logic. We have someone who works with engineers on thermal energy storage. We have folks that work in data ranking, medical statistics, other applied statistics, ergodic theory, which is a type of probability, and then your other pure math topics like topology, number theory. So we have a lot going on. We would love to see any of you in the math department. It's a fantastic major. It's also a really good minor and double major. So anyone who has questions, please email me at jurishc.cfc or Kate Owens, and hope to see you. Back to you, Patrick.
Wonderful. Thank you so much, Liz. And last, to talk about physics, we have Dr. Kusa Rummel, affectionately known on campus by almost everyone as NK, but I will hand it over to physics. Just to check we're not on mute.
Yeah, thank you, Patrick. Hello, everyone. I am NK, and I received my undergraduate and graduate degrees from India. I joined the College of Charleston in 2004, and my research involves nanomaterials for medical and energy applications. So as you can see on the slide, we continue to keep our status as one of the top undergraduate departments. According to the American Institute of Physics data, there are 503 undergraduate only departments, and we are number 15 when it comes to the number of undergraduate degrees awarded. That's in physics and astronomy. And we are the only department in SC offering astronomy, meteorology, and most recently, the systems engineering degree program at the college. So as you can see, we offer BS and BA in physics, BS in astrophysics and BA in astronomy, BA in meteorology and secondary education. And we offer 2 new engineering degree programs, BS in systems engineering and BS in electrical engineering. And as you can see, we have a very diverse and friendly faculty within the department. I must actually stress, we are very friendly, okay, to our students. I think that's very important. And in addition, we also offer several concentrations, including energy protection, computational neuroscience, operational meteorology, atmospheric physics, and minors, physics, astronomy, meteorology, neuroscience, biomedical physics, and a very interdisciplinary minor that is business applications of weather and climate. So we are a very productive department. Undergraduate research is our highlight. As you can see, our faculty were very active in publishing papers, and most of them actually include undergraduate research students. And that means this is an undergraduate only department, but you actually get graduate level experience, in participating in some of the research activities. So undergraduate students published, and they also present their work in several conferences. So it's very research active, and research is required. Before you complete your degree, you have to do at least 1 semester of research. And if you can move to the second slide. Here, you can actually see some of the areas of research. If you are interested in astronomy or astrophysics, we have actually faculty expertise, internationally known faculty doing extrasolar planets, gamma ray bursts, massive stars, black holes, stellar explosions, and how planets are formed. And material science, we have faculty doing semiconducting materials, composite materials, including carbon materials that Dr. Vandelden just showed you, thermoelectric materials for energy production, magnetic materials, ultra fast dynamics using very fast lasers, 10 raised to minus 15 seconds, femtosecond laser systems, soft matter physics, and non-destructive characterization of materials. In medical physics, we have faculty doing photodynamic therapy, modeling of single cell and biological neural networks, polymer nanomaterials for cancer treatment, and then identification of precancers of the cervix. Meteorology, we have atmospheric microphysics, how raindrops are formed and what happens to it, and also nucleation, ice nucleation, and inner structure of hurricanes and low country weather specifically. And also we have systems engineering, organizational performance measurement, system dynamics, engineering management. Our electrical engineering program is focused or concentrated more towards autonomous electric vehicles, networking, and IoT means Internet of Things. Okay, so very diverse areas of research that actually fits to your interest. And we have several cool toys, within the department to play with. That includes a brand new observatory telescope and an electron microscope, atomic force microscope. You already saw, Dr. Vandelden is actually in one of those labs. You can see right there. Several spectrometers, spectrophlorimeters, laser systems, X-ray diffraction units. You just name it. I mean, so if you're a hands-on person, you can actually play with several cool toys within the department. So we have also computational facilities. If you are a computational person, you can also do computational research work or theoretical research. Okay, so we have opportunities for theoretical work, computational work, and experimental work. If you have any questions, please contact me. Let me type it in the chat box. You can contact me, nkkutirummaln@cofc.edu. Okay, or please feel free to call me. You can always visit our website, or you can call me. I'll be happy to arrange a Zoom session, or you can call me and talk to me if you have any questions. Okay, so thank you all. Back to Patrick.
Wonderful. Thank you so much, NK. So there we go. We've had a chance to go over a number of different areas within our School of Sciences and Mathematics. There's obviously a lot for our students to get involved in terms of majors and minors and research opportunities. Looking here in the chat, I think we've got one question that came in about internships. And I think we got an initial answer to it, but Sebastian, if you want to kind of take charge in terms of any other notes on the internship front.
Yeah, totally. And somebody else private messaged me a question, which I'll ask Eric McElroy to answer here in a minute. But yeah, this is the time to put your questions in the chat box, right? So get them in there so we can try and do our best to answer anything that's on your mind. But in terms of internships, there's lots of that in Charleston. I mean, we just have an embarrassment of riches here in Charleston in terms of all the industry that you can engage with and get an internship or co-op while you're still a student here. Just yesterday, I was on a Zoom with Thorne Pharmaceuticals. So they're a pharmaceutical manufacturing company here in Charleston. They make 1 billion pills a year. They need all of our graduates, no matter what the major is. But I get on the Zoom with HR folks, they want more of our students. And I'm seeing a couple people, and I'm looking, I'm like, Cody, is that you? So Cody, one of our chemistry recent graduates, did a summer internship there. And of course, they gobbled them up right away. So the internships or paid internships, we only promote paid internships in our school, are a great way to get your foot in the door, get you the experience, you do a good job, then they'll hire you right afterwards. Co-ops are not as common as internships. A co-op means you go to work for the company full-time for 7 months or so at a time, typically 2 times throughout your college experience. So we've codified 2 co-op programs for both of the engineering programs, because those are more common in engineering, but you could go to work for Bosch literally for a whole year while you're a student here full-time. And then of course, you're a no-brainer for them to hire as soon as you graduate. So yeah, there's lots of that in Charleston. The other question I got that I'll turn over to Eric is related to study abroad opportunities for biology students. Eric, could you share with us any thoughts on that?
Yeah, so I actually had to make a list because we've done a bunch of these over the years. So currently we have study abroad programs this coming summer in the British Virgin Islands, in Panama, and I think we had one scheduled for New Guinea. I'm not sure if that one's going to happen. Two of those programs are marine biology focused, so very focused on diving, coral reefs, things like that. And then the program in Panama is a combination of some marine biology and then some terrestrial rainforest biology. Over the years, we've also had programs in the Amazon, in Bali, in Panama. Those are summer programs. And then during the academic year, we participate in a program in Trujillo, Spain. And so you can go do that for an entire semester. You take a couple biology classes and then like usually a business class, and can't remember what the other class is, but it's like it's a full slate of college classes that you take during the fall semester at Trujillo. We've led that program, I think, 3 or 4 times over the past decade. So lots of opportunities.
Thank you, Eric. See.
All right, I see another one in there, Sebastian. Will there be a chance to tour the science department and marine biology facility during admitted honors student sessions?
Somebody else might have to help me out with this. I know for the accepted student weekend events that we're doing, part of it is a Build Your Own Campus Tour experience where you get to see me again, and a lot of the characters here on the screen will be right outside the Rita Holland Science Center, kind of doing a tabling event. You come talk to us in person, and then you can explore the science buildings. They're all open. You can explore them kind of on your own. It'll kind of point you in the right direction to the 2 big science buildings here on campus. Marine biology is not typically a part of that experience because it is a 15-minute drive away at our Fort Johnson campus right on the water, as Dr. McElroy was talking about earlier. But for the honors accepted student activities, I know there are specialized sessions depending on the major of your choice. So things might be a little bit different, but I don't know if anybody else can put a finer point on that. I'm welcome to help.
I can just chime in quickly. We've talked about doing that because lots of students are very interested in seeing that facility. But as far as I know, so far this year, we haven't had anything formally worked in, again, because it's, to get out there and back and do a tour is a couple hours, and we're so busy on campus doing other parts of the tour that just doesn't always fit in. The other issue is that most of these tours happen on the weekends, and the facility has an electronic gate, and we can't get through on the weekends. Well, faculty can get through, but students, of course, prospective students couldn't. But yeah, individually, so if you come during the week, we try to arrange something for you. So contact me and I can help make that happen if it's possible.
All right, Sebastian, you want to take the next one, or do you want me to pitch it out to the crowd?
I see one there. What are the study abroad programs for geology? And I think Dr. Persons kind of mentioned them quickly, but Dr. Persons, would you like to just talk about those real quick? Yeah.
Sure. So the field studies program that I'm running this summer is in Glen Rock, Wyoming, a town that's so small it's even difficult to Google. But it's a great location with dinosaur hunting ground right in the backyard. There's also this summer work being done in the Colorado, along the Colorado River. But as the pandemic lessens, of course, there's work done in India and South Africa. And there's also work done in the Four Corners region of the American West, which goes around to a lot of really, really cool geologic sites.
Hey, Scott, while you're at it, I think you're on a roll here. I see, we'll skip over a question maybe since we got you. If we are planning on pursuing a geology major with the new concentration in paleontology, can we start with that concentration, or do students have to study for a certain time or take a certain amount of number of courses before that concentration becomes available?
So you can start to work on some of the courses that are required for the paleontology concentration and the geology major right off the bat.
Awesome. Thank you, Dr. Person. The question I skipped over, getting a STEM degree is hard. Yes, yes, it is. What do you guys offer in terms of rigorous study sessions and other issues that might arise? So yeah, totally. So all of our majors, no matter which one of the 17 that we offer right now, we're developing 2 more that might be available this fall. We don't want to talk about them because that might jinx the final approval of those new programs, but they're super exciting. And they're all rigorous, right? There's a lot of foundational math and science and stuff. So, you know, time management is so important. When you come here this summer, you'll do your orientation session, you'll see me again, then you'll split out in your respective departments, and we'll start right off the gates, acclimating you to the various facilities on campus and where you can go get help. Try to get you on a good time management. Time management is so important when you first go to college. So we try and help instill those ideas in you right off the gates. The library is located right in between the 2 big science buildings on campus, and it houses the Center for Student Learning, which includes tutoring labs for each one of our STEM programs here. So that's a great go-to resource for you. For some of our programs, we offer SI sections, supplemental instruction sessions, but the first person you go to with questions is your professor. We want you. I can't tell you how lonely I am in my office when nobody comes to ask me questions. I love for students to come ask me questions. It shows me that you actually care about the stuff that we're talking about in class. So please, please, please don't hesitate to ask for help, number 1, and then go to your professor as your first line of defense if you have a question, you don't understand something about homework or what was covered in class or whatever. Professors want to see you, want to have you ask questions.
Sebastian, and just to echo that, you know, one of the things I always, you know, traveling around meeting with students and obviously visiting on campus, that is, I think, one of the great things about College of Charleston is though we do have some great graduate programs, we have an incredible undergraduate focus. And so all of our faculty, especially the people you see here tonight, the department chairs and different faculty members, right, they're all here because they like working with undergraduates. They like being engaged with students at this point in their academic careers, helping them figure out what challenges they want to go after, what things they want to explore and learn more about. And that's, I just think, one of the really strong things about the College of Charleston, besides the great resources and focuses and the ability to do the research, it's that the faculty are so engaged in that undergraduate experience.
I see a question. Next question here in the chat from Ava is, want to be a physician's assistant. I saw CFC just opened up a new School of Health Sciences. Can you talk more about the School of Health Sciences and the difference between this and the health professions advising? So yeah, we had an exciting announcement that, you know, pre-health stuff is so big, what we do here at college, that we're standing up a whole new school that focuses in those areas. And we're kind of progressing towards all the implementation of that new school. So it's going to be a little while before the school actually takes shape and gets settled and really codifies, and we figure out how it impacts the other programs on campus. So it was an exciting announcement. And for the meantime, as we work towards standing up that new school, nothing's really changed. So Karen is still your go-to expert for all things pre-health. And I'll turn it over to Karen if she'd like to add anything to that.
Yeah, we've been doing this for, I mean, I've been at the college for over 16 years, and health professions advising has been going on prior to that. When we actually started we opened the office 16 years ago, and we get more than 100, it depends, it varies depending on the year, but we have never in 16 years put less than 130 students out into the healthcare field. So usually our acceptance rates, we've been as high for medical school as 58%. We usually hover somewhere around 48 to 50, and that's compared to national averages of about 42 to 45. So that number may not sound high to you, but we feel like we're doing pretty well. And I mentioned earlier that the head of the program coordinator for our EMT program is going to Yale for her PA program. We also have 2 students who started this summer at Duke University in the PA program. So we feel like we do a pretty good job of being competitive with those programs as we stand with or without our future developments in place.
Cool. Thank you, Karen. And you know, something Karen mentioned earlier, even though biology, biochemistry, chemistry are popular choices when you're pre-med, it's pretty cool that you can literally major in anything here at the College of Charleston and be pre-med with Karen as your advisor. One of my advisory board members is a hyperbaric wound doctor in Spartanburg. She was a German major at the College of Charleston, but did all the prerequisite, you know, pre-health coursework, and of course has been having a very successful career. And that will not change at the College of Charleston. That will certainly remain in place as we kind of move forward. I see the next question though is, can you speak to electrical engineering, more on the electrical engineering program? Normally I would hand that off to NK, but I just can't help myself. So I need to, I'll try and talk a little bit about that. First, NK and I were two of the rascals who helped establish these engineering programs here at the College of Charleston. The electrical engineering program just started, is in its first year. It does have a focus on autonomous electrical vehicles. It's a very traditional EE program, but you do have to take a course in mechanical power conversion. So when you push the gas pedal, how do you make the electrical vehicle go? Wiring and all the sensors, make it go down the road by itself, just generic vehicle design and a few others. But it's overall a pretty typical EE program. We have the EE, the autonomous electrical vehicle focus though, because Volvo is here in Charleston to make the sedans, and then they're gonna make an SUV for the American market starting next year. Again, only place in America, Volvos are made here in Charleston. Mercedes makes the Sprinter van here in Charleston. They make Sprinter vans at 5 places in the world, but the Charleston facility will be the lead facility in the world for the E-Sprinter van, the electric Sprinter van. Starting next year, Bosch is going to start making electric engines here in Charleston. So for all these reasons, it has the autonomous electric vehicle flavor to our electrical engineering program. Anything to add, Inke? You're on mute.
Yeah, this is as Dr. Vandelden mentioned, this is a traditional electrical engineering degree program, but with more focus on, you know, autonomous vehicle systems, electric vehicles, and that's going to be the future. So you'll be actually learning traditional plus more recent developments in electrical engineering. And we also concentrate on industrial automation, you know, so you'll be also learning more about industrial automation systems if you enroll in the electrical engineering degree program.
And we're on a roll. So the very next question is, can you talk a little bit more about systems engineering? You know, systems engineering is a broad-based engineering discipline. It was the first one we stood up a couple of years ago. It's in its sophomore year now, juniors next year. And it's more similar to industrial engineering, but there's a heavier computer science programming aspect to it. So if you really like the programming sense, you in your upper level course where you can go the data science route or the cybersecurity route, 2 areas of engineering that are very important as all these factories are going very high tech into the future. There's a business core of courses, general business management, Lean Six Sigma stuff. So that's quality assurance stuff. You're producing things, making sure you're minimizing the errors. Operations, research, and supply chain logistics, which are, of course, very relevant topic for this day and age. You take a little bit of electrical, a little bit of mechanical, design, CAD stuff. And then, I mean, the power of this program, like most of our programs, is that in your capstone course, you're going to be working on a project for one of the industries in the area. If you go to the website, you'll see all the companies on our engineering advisory board. And that's something we do very well in computer science department. We're working on 22 projects for 22 companies this semester. We have a professional scrum master from Booz Allen helping us to teach that course, along with Professor Stalvey is teaching that course. So we do a pretty good job integrating our students with the companies in the area. But the next question I really think is for NK. NK, are the internship opportunities within the physics department?
Yeah, a lot of internship opportunities. They actually go to industries to do internship, like Boeing, for example. They also go to local TV stations, you know, if you're a meteorology major. More recently, and one of our students actually got a job there, you know, after doing her internship. So yes, a lot of internship opportunities that includes more kind of engineering oriented applied physics, and also, you know, computer programming interns, weather forecasters. Yes, a lot of opportunities.
Last call for questions.
Okay. Well, I do know, obviously through all these different presentations of the different departments, our faculty, our department chairs, everyone I think was so helpful in sharing their contact information. And hopefully one of the big takeaways, right, is engagement. These are faculty members who want to talk to you, who want to answer questions. Obviously, if you're visiting campus, they'd love to see you firsthand and have a chance to kind of get connected to you. So please do continue the conversation. Please feel free to reach out to them. Go on the website, you'll find contact information for all the different departments, all the faculty members you see here. Again, we thank you all for being here tonight. I'm going to hand it back over to the Dean of the School of Sciences and Mathematics, Sebastian Vandelden, who's been our host for the evening. So again, thank you all for being with us today. Looking ahead for seniors going through, into the final process here. We are obviously moving forward and looking towards that May 1st final decision date. So we are, as you're going through it, and once you know that Charleston's the school for you, we definitely encourage you to get those deposits in. Go ahead and get the housing application in, start making all those steps. But you'll continue to see updates from us in terms of additional events, both virtual and in person. So on behalf of the Office of Admissions, I do thank you all for your attention and being with us this evening. And with that, I'm going to hand it back over to you, Sebastian.
Thank you, Patrick. I really appreciate all my colleagues joining us tonight for this session. And of course, really appreciate you, our future College of Charleston students, for spending some time tonight. We've covered a lot of ground, right? So please do reach out to us tomorrow, next week, next month. And I really do hope we'll get to meet you here on campus and get to chat in person very soon. With that, I think it's time to close out. So I hope you have a great evening. I look forward to seeing you soon in person.
Thanks, y'all.
Tuesday, and I've done nothing Monday,